Hi everyone, in this video I will show you how an 8-bit binary adder works and how to build it from nothing in Minecraft. First we have to start with understanding the binary number system. If you have a signal, it means 1 or true. If you have no signal, it means 0 or false. The binary number system consists of ones and zeros. If we add 0 and 0, we will get 0 as a result. If we add 1 and 0, we will get 1. If we add 1 and 1, we will get 1 0. Second, we have to understand how different logical elements work. Element NOT. This one flips the signal. Ones becomes zeros and conversely. Element OR. This element is being triggered if one of the two contacts has a signal. This element can be replaced by one redstone dust. Also, it must not pass the signal from one input to another. Please watch for this in your builds. Element AND. This element is triggered when two inputs have signals. This one is based on two comparators in subtraction mode. A single red lamp must glow to activate subtraction. One power block in the back of the comparator and input contact on the side. When input has a signal, the comparator subtracts the input signal from the signal of the power block. The input signal always must be equal or higher than the signal of the power block when it's triggered. Otherwise it won't work. This wall element has to output signal when it has both inputs without signals. In this way it works in inverse ratio, so we must add element NOT to each input. Now this works fine. We are ready to assemble the first logical scheme called quarter adder. Simply it works like that. We have two inputs. First input goes to contact 1 and 3. Second input goes to contact 2 and 4. Contacts 1 and 4 both have the element NOT for each. The next stage is the element AND, which receives both raw signal from first input and answer from element NOT from the second input. Finally, element OR, which function is done by this redstone dust. You can also change it with a solid block or other redstone parts, depending on what type of adapter you want it to be. Redstone lamp shows the result of the logical calculation. This quarter adder shows only the number of first discharge of the final result. So if we have 0 plus 0, then we got 0 as a result. 0 plus 1 equals 1. 1 plus 0 equals 1. But if we add 1 plus 1, we get 1 0. This sum indicator shows only the number of first discharge of the sum, which is 0. This is why we need to bring out the next digit of number discharge in the calculation. By the way, this logical scheme also works as element XOR, exclusive OR. Exclusive disjunction is a logical operation that outputs true only when inputs differ. One input is true and the other is false. So, indicator outputs signal only if one of the two inputs has a signal, otherwise output is 0. We are back to our step-by-step scheme. Next logical scheme is called semi-adder. We have the same quarter adder, but at the same time we put both inputs through another element AND. Now we have numbers of discharge 1 and 2. If we add 1 and 1, we will have result 1 0, shown on indicators. If we want to build more than 2-bit adder, we must consider the number of previous discharge in the logical scheme. This is why we need to add an input for the number of previous discharge. So, now we see the complete logical scheme called adder, which is ready to be a part of a big sequence. What's new in this scheme? We have a quarter adder sequence of two parts one by one. The first one is without changes, but the second one takes the sum of the first quarter adder and number of previous discharge and gives us the sum of them both. Another output stands for the number of next discharge, which could be the signal for the next logical scheme in sequence or signal for the final result. This one is made of two elements AND. The first element AND turns on if the sum of first quarter adder and previous digit number both have positive signal or both true. For example, the previous digit number is 1, and the sum of first quarter adder is 1. They both turn on element AND, which stands for the next digit number for the next logical scheme or final result. The second element does the same, but takes signal from inputs. Why do we need two elements AND here? If we have the number of previous discharge 1 and the sum of the first quarter adder 1, then the number of previous discharge will be the answer of second quarter adder, and the sum of first quarter adder will be an answer of the number of next discharge. Secondly, if we have both input stands for ones and the number of previous discharge 0, then the sum of first quarter adder will be 0, which means we lost the number of second discharge, and the indicator for the number of next discharge will show this lost value of second discharge. After lots of attempts of decreasing this logical scheme, I finally got the smallest one which I could create in Minecraft. We got 3 inputs, first and second input for input signals. The third input is the number of previous discharge. And 2 outputs, which are the number of next discharge and sum of this logical element. Finally, we have made this whole trip to make a small 8-bit binary adder. The first one is made of user interface panel, where you have levers to input your numbers and results indicator, which shows the result of adding these 2 lines of numbers. We have 9 indicators due to the number of last 8th discharge, if both inputs got positive signals. This 8-bit binary adder has a sequence of 8 complete logical adder schemes. I believe this is not the highest density of the layout, so this looks like it is a lot of space, but I have done everything I could in a short amount of time. As a result, these levers activate tracks, every one of which goes to its own input on the logical scheme. Series of 8 schemes are stacked vertically in my build. They go from 1 to 8, starting from the bottom, where the first element is responsible for the number of first discharge, and the 8th element stands for the number of 8th discharge. They are linked as the number of next discharge in the previous element, and the number of previous discharge in the next element. The first element has 0 on the number of previous discharge, because we have nothing before the number of first discharge. The 8th element has its output linked to the 9th indicator on the results display. Each sum results of every logical scheme goes to its number of results displayed respectively. Lastly, I have made another version of the same adder, but in this version it has 2 columns. Each includes 4 logical schemes connected to one another in the same way, but a little bit tricky connections due to redstone rules in Minecraft. It has definitely got smaller, with the total space taken 11,875 blocks, compared to the first version of 12,375 blocks taken. On the other hand, the second version takes maybe less than a second longer to compute results. In my opinion, longer computation time and elements that are harder to connect were not worth the space saving. But this gave me a lesson on how to connect bigger parts in the future complex structures. Also, this adder can be done in any bit depth value starting from 2 bits. My binary adder got 8-bit depth. Now, how do you feel about building your own adder? Thank you for watching, my name is Ruslan, hope you enjoyed. See you in the next videos.